flowing through a loop. So here in nodal analysis, we have to find out the voltage value where current is passing through the loops. So here the loop is also considered here as loop 1 and loop 2, whereas we write as loop 1 and loop 2. For mesh analysis, we can apply the KVL, Kirchhoff's voltage law. Here in nodal analysis, we can apply KCL, which is Kirchhoff's current law. So here, firstly, we have to know about what is Kirchhoff's current law. So the KCL is the algebraic sum of incoming current is equal to the algebraic sum of outgoing current. So it is considered as a junction, whereas incoming and outgoing current are, so this is incoming current, this is outgoing current, incoming current and outgoing current, where we can write it as I1, I2, I3, I4 and I5. So these are all the different types of current which is coming inside the loop and getting outside the loop. So here the algebraic sum of all these incoming current is also equal to the algebraic sum of outgoing current. Whereas I1 is considered as an incoming current, and I3 is also incoming current, I5 is also incoming current. So these all the incoming current is equal to the outgoing current. So this is the concept of Kirchhoff's current law, whereas all the incoming current is equal to outgoing current. So the junction point, the node point is always 0. So here we are applying the nodal analysis by KCL, which is Kirchhoff's current law. So here we can consider the flow of current in an arrow mark. So the arrow mark consists of tail end and arrow end. So this is tail end and arrow end. So by considering this tail end and arrow end, we can consider these voltage to the node 1. So here how we can find out the node is 3 or more junction joining together is known as a node. So here these branch and these two branches is considered as 1, 2 and 3. These 3 branches meeting at a point is considered as a node. So in this complete circuit, we are having a single node equation where that single node is known as V1. So here all the loops are connecting in a point that is grounded. So that is considered as a reference voltage. So the reference voltage is always a V reference is equal to 0 voltage. So in every circuit, for each and every reference voltage, we can consider that as 0. So rewrite the equation in this circuit as applying KCL at node 1, V1, that is V1. So if you are having another node V2 means we have to apply the node equation for V1 and then for V2. So as like this, we solved in the mesh analysis problems. So in KCL, node 1 V1 voltage, here the tail end is 20 volt and the arrow end is V1. So the incoming current and outgoing currents are I1 is act as an incoming current, and whereas I3 is also an incoming current, where I2 is an outgoing current. So the algebraic sum of I1 plus I2 is equal to I3 is equal to I2. So here I didn't write it as I1 plus I3 is equal to I2. So whereas the I1 is considered as the 20 volt is an arrow tail end and V1 is an arrow end. So 20 minus V1 divided by the voltage resistance across this voltage source is equal to 6. Whereas in I2, I write it as I2 V1 is in tail end and reference voltage is an arrow end. So I consider V1 minus 0. So 0 that is negligible. V1 minus 0 divided by the voltage resistance across this voltage is 8 volt. So whereas in I3 voltage, I3 current 10. So V1 12 volt is in tail end and V1 is an arrow end. 12 minus V1 divided by across the voltage resistance is 10. So I rewrite this as like this, and then we can solve an equation. So after rewriting the equation, we can get the equation like 20 by 6 V1 minus 6 plus 12 divided by 10 minus V1 divided by 10 minus V1 divided by 8 is equal to 0. So after all these, the algebraic sum is equal to 0. So solving, taking LCM for these all values, we can get V1 is in common term V1. So taking LCM for all these values, we can get minus 47 divided by 120 plus the constant value is 68 divided by 15. So here we can rewrite this equation constant values in the another side. So that 68 divided by 15 this goes on the another side. So V1 is equal to 68 divided by 15 into 120. So reciprocating these values and getting LCMs, we can get the V1 value as 11.57 volt. So here V1, so node 1 voltage is find it as 11.57. So here the question is also the possible question as find out the current across the 8 ohm resistor. So that current across the 8 ohm resistor is obviously I2, whereas the branches in I2 value. So I2 is equal to current across the 8 ohm resistor. So here we can again apply the nodal voltage sources. So considering these loop, so I2 loop, we can have a value of 8 amps. So we rewrite it as it is on tail end. This reference voltage is on arrow end. So tail end V1 minus 0 divided by 8. So here, why we are writing this as V1 minus 0 divided by 8? Because of we have to find out the 8 ohms resistor across the current 8 ohm resistance value we have to find. So that I8 ohms equal to V1 minus 0 divided by 8. So I8 ohms is equal to V1 divided by 0, 8 is equal to V1 is considered as 11.57 minus 0 divided by 8. So 0 is negligible. 11.57 divided by 8, we can get the value of 1.446 amps. So here we are finding out the current value across the 8 ohm resistor. So the value is denoted as amps. So these are all the things which we have to consider in a nodal analysis. So this is a two loop or single nodal analysis